Okay, let's get a little more complicated. So solving equations with variables on both sides. So we've looked at equations that just have one step. We've looked at equations that have more than one step. And we've looked at equations that also have that distributive property in there. So this last piece that we're going to pull together is when the variable appears on both sides of the equation. So we haven't seen that yet, so how do we figure out what to do with that? Our steps are really the same. They're very similar in what we've been doing, so we're still going to look for, get rid of parentheses first, we're going to deal with any exponents if they appear, we're going to combine like terms, and we're going to kind of simplify both sides of the equation until we can't simplify it anymore. Then we'll start by adding and subtracting from both sides until there's nothing left to add and subtract, and then we'll deal with multiplying and dividing last. So let's take a look at three problems. So this first one, r equals negative 5r plus 18. So again, you'll notice that there's an r on both sides of the equation. Remember, my equal sign is the middle of that equation. So there's no parentheses here, so I don't need to worry about distributive property. My left side is just an r, so there's no like terms to combine. And my right side has a term with an r in it, and then just a constant. So there's no like terms to combine there either. So what I want is I'd like both of those terms that have the r in them to be on the same side. That's where I'm going to focus first. So I want to get everything with an r on one side. Now, I could get rid of this r. This is just a positive r, so if I subtracted r, I could do that. I could subtract r from the left and subtract r from the right. Now, the only problem with that, and it's not wrong, it's just kind of funky looking, is that I would end up with 0 on the left-hand side, and we can totally deal with that. It's actually pretty easy. We'd end up with our term of r and our constant on one side, and we'd just then add or subtract to get one back on the other side, so we had something on each side. However, a way to avoid doing more than one step is to take the r from the right side where the 18 is. We're going to leave this, since this is the only constant, we'll leave it there, and we'll move everything with an r to the left-hand side. We'll leave this 18 over here by itself, and we'll put everything with an r on the left. So to get rid of a negative 5r, subtracting 5r, we're going to add 5r to both sides. So I'm going to add 5r to both sides. Remember, this is a 1r here. Remember that whenever we have a variable with no number in front of it, there's always a 1 there. So that's a 1r. So 1r plus 5r gives me 6r. And these two cancel out, which leaves me with 18 on the side. Now this should look very familiar to you, because that's what we've been working on problems and getting it to this. This is where we're at our last step, multiply and divide. So again, we're going to focus on the adding and subtracting first, and then we'll worry about the dividing and multiplying last. So here, we're multiplying by 6r divided by 6. We get r equals 3. So the main difference here is that you're going to see the variable on both sides, but we deal with it the same way we dealt with the constant on both sides, by adding or subtracting it to get those constants together. Same deal with the variable. So let's take a look at b. b has a lot more going on here. We have parentheses, so we'll have to deal with our distributive. So first thing we're going to do is look inside the parentheses, see if there's anything we can do. So 1 minus 1 half x, no like terms there. X plus 1, no like terms there. Again, remember this is a 1x. I can't combine like terms. So now I'm going to distribute. 6 times 1 is 6. 6 times a negative is a negative. Positive 6 times a negative 1 half. 1 half times 6 gives me 3, 3x. So I have 6 minus 3x on the left. On the right side, 2 times 1x is 2x. And 2 times positive 1 gives me positive 2. Alright, so from here we want to get all the constants, just the plain old numbers on one side and all the variables on the other. I usually tend to deal with the variables first. You don't have to, you can deal with the constants first, that's fine. So I need to get this negative 3x and this 2x on the same side by doing the opposite to one of them. So I could do two things. I could get rid of this 2x by subtracting it, but that would mean there'd be a negative over here on the left side, which I may end up with a negative. That's life, that's how it goes. But let's avoid it while we can. So instead I'm going to add 3x to the left side, and I'm going to do that to both sides to even it out. These two cancel each other out, so that's gone on the left side, but I had to do it to the right side also. So I end up with just plain old 6 here on the left. 2x plus 3x gives me 5x, and then I've got a plus 2 hanging on the end. This should look familiar. We've seen this. So from here, I'm going to leave the 5x alone. I want to get rid of the adding 2 by subtracting 2. So I end up with 6 minus 2, which is 4. And from here, I don't have much choice about what to do. I need to get the x by itself. So I want to divide by 5, since we're multiplying by 5. Divide by 5, and I end up with 4/5 equals x. Don't worry about the fact that the x is on the right-hand side. Doesn't really matter where it ends up. If you want to, if you don't like it on the right-hand side, you can just switch it around. Take these two sides and just switch them. So instead of 4/5 on the left, we'll put it on the right, and we'll put the x on the left-hand side. You could also, if you're not a fraction fan in this particular case, since we didn't start out with any of them, you could change it to 8/10 if you wanted to. Take it that way. All right, let's try. I think we've only got one more here. Yep, one more, but it's got a bunch of stuff going on. All right, so I've got parentheses. I've got variables on both sides. So the first thing I'm going to attack is with parentheses. So 3y minus 2. Nothing on the inside here to combine like terms, so I'm going to do distributive property. 3 times 3y is 9y. 3 times negative 2 is negative 6. Again, remember, if you want to, you can change that to adding the opposite. On the right-hand side, inside my parentheses, 3y plus 2. No like terms there, so I'm going to distribute. 2 times 3y is 6y. 2 times 2 is 4. And then this extra 2 is hanging out on the outside. Now notice that the 2 is attached to the parentheses, and this is where the parentheses end. So I'm only going to distribute up to where the parentheses end. It's 2 of these and 2 of those. This doesn't have anything to do with the parentheses. It's just kind of hanging on at the end there. So we're just going to bring that plus 2 down. Just kind of comes along for the ride. Haven't done anything with it yet. But now we realize that we've got some like terms over here on the right we can combine. So I end up with 6y plus 4 plus 2 is 6. I didn't do anything over here on the left side because there's nothing to do. So I just brought it, just copied it down again. Now I have 9y minus 6 equals 6y plus 6. So from here, I want to get all my variables on one side. So I have 9y on the left, 6y on the right. I chose to subtract 6y so that I could have a positive 3y over here on the left. You absolutely could subtract the 9y. That would be totally fine. You'd end up with negative 3y on the right. That works just as fine. There's nothing wrong with it. I just prefer to, if I can get that to be a positive, then I do it. So I've got 3y here. This negative 6 comes along. These 6y's cancel each other out, and so this 6 comes down here with us. So now I have 3y minus 6 equals 6. Do this out. Don't suddenly say, oh, things cancel out here. I want to get this 6, remove the 6 here, so I'm going to add 6 to both sides. Notice I ended up with 12 over here. The 6 didn't just cancel each other out. Now I have 3y equals 12. I'm going to divide by 3 since I'm multiplying by 3 here. Divide by 3 on both sides. I end up with y equals 4. And remember what this means is that if I took a 4 and put it back into this equation, if I took out every y that I see and put a 4 in there, these two sides would be equal to each other. So 3 times 4 is 12. 12 minus 2 is 10. 3 times 10 is 30. Over here I've got 3 times 4 is 12. 12 plus 2 is 14. 14 times 2 is 28. 28 plus 2, 30. So this number is the number that makes the two sides equal to each other. So we're kind of adding that last element that we're really looking at with our linear equations of seeing the variables on both sides. But it's not really anything new. You've really already done it. It just looks a little different.